This video is to give you an example of how to complete this osmosis worksheet. We're going to do the middle one right here, and I'm going to show you each step so you know what you need to do. So on here, what you're doing is you're showing me how the water is going to move based on the type of osmosis solution. Now you should already have a little bit of knowledge of these solutions because you've completed notes on these. So make sure you know the difference between isotonic, hypertonic, and hypotonic solutions. If you don't, I would pause now and go back and look because that is pretty important in order to do this. Okay, the first thing we're going to do is we're going to look at our beaker. That's what this is. It's a beaker. We have the outside, as in the water in the beaker, and then this circle is the inside. This is the cell. If you look, it has H2O and it has solute. H2O is the water. Solute is the solid, usually salt. We are worried about the water. The solute is only there to balance the inside and the outside because the inside of the cell needs to equal 100% and the outside of the cell needs to equal 100%. Look at each of them. 90 and 10 make 100, 85 and 15 make 100, 40 and 60 make 100, 90 and 10 make 100. So the inside needs to be worth 100% and the outside needs to be worth 100%. So first thing we need to do is to draw an arrow to show which way the water would move by osmosis. Remember, osmosis is passive transport, so there's no energy needed. So it's going to move from a high concentration to a low concentration. I always think of a ball on a hill. If I put a ball at the top of a hill, it'll roll down. That's passive. It'll do that because of gravity. But if I put a ball at the bottom of the hill at the low spot and try to put it to the high, it's not going to roll up on its own. I'll have to move it. So passive transport has to go from high, the top of the hill, to low, the bottom of the hill. So if we look at this example here, where's the high amount of water and where's the low amount of water? The high amount is here at 90. And the low amount is here at 40. So we're going to move from high to low. So my arrow is going to go into the cell because that's the way the water is going to move. Now the second one says to fill in any missing percentages. The front doesn't have those. That'll be the back. But remember, the inside should be 100 and the outside should be 100. After that, you're going to identify the type of solution. So remember, isotonic solutions are equal. The inside and the outside should be the same. When they're like that, you will draw a double arrow, an in and an out. That's not a great arrow, but you know what I mean. So that would be our example for isotonic. Hypertonic is when it goes from inside the cell to the outside, and the cell is going to shrink. So that's when the high was inside the cell, and our arrow would come out. Hypotonic is the opposite. That's when the outside has more and it fills the cell, making the cell bigger. I always remember hypo like hippo because hypotonic is going to make the cell get bigger like a hippo. So this example, since water is high on the outside, it's going to go in and make the cell bigger. This is a hypotonic solution. So down here, maybe in the cell, maybe below it. I think I'm going to go below. We write hypotonic. Now I'm doing this with a mouse, so this is pretty hard. You should be better with your hand. I'm going to stick with hypo, but you should write the whole name, hypotonic. That's all you need to do. Do that for each of these examples, and if you have questions, either check back here on the assignment video or ask me.